Sudo. What is Sudo? Sudo is a program that lets users run other programs with the security privileges of other users. By default, that other user will be root. A user generally needs to enter their password to use Sudo, and they must be permitted access via rules in the /etc/sudoers file. Rules can be used to limit users to certain programs and forego the password entry requirement. Here are a few useful commands to run with Sudo. To run a program using Sudo, simply type Sudo followed by the program name. To run the program as a specific user, you must include the -u command line option with the username. To list programs a user is allowed and disallowed to run, you can type Sudo followed by the -l option. Known passwords. By far the most obvious privilege escalation with Sudo is to use Sudo as it was intended. If your low-privileged user account can use Sudo unrestricted, i.e. you can run any programs, and you know the user's password, privilege escalation is easy by using the switch user or su command to spawn a root shell. If for some reason the su program is not allowed, there are many other ways to escalate privileges in this manner. Here are a few options. You can run sudo-s, sudo-i, sudo/bin/bash, or even sudo password to try and change the root user's password. Even if there are no obvious methods for escalating privileges, we may be able to use a shell escape sequence. Shell escape sequences. Even if we are restricted to running certain programs via Sudo, it is sometimes possible to escape the program and spawn a shell. Since the initial program runs with root privileges, so does the spawned shell. A list of programs with their shell escape sequences can be found at the URL displayed. Let's run the Linux Smart Enumeration script without it prompting for a password. We can see in the results that our user is allowed to run several commands via Sudo without a password. To find this out manually, we can just run sudo-l. Let's pick one of the commands, find, and go to the GTFO bins website. We type find into the search, and it appears there is a Sudo-related escape sequence. We can copy this command and then use it to gain a root shell. Abusing intended functionality. If a program doesn't have an escape sequence, it may still be possible to use it to escalate privileges. If we can read files owned by root, we may be able to extract useful information, e.g. passwords, hashes, keys. If we can write to files owned by root, we may be able to insert or modify information. If we list the programs our user is allowed to run using Sudo, we can see that Apache 2 is in the list. Apache 2 does not have any known shell escape sequences. However, when parsing a configuration file, it will error and print out any line it doesn't understand. We can use this to read the first line of files which we ordinarily do not have access to, such as the /etc/shadow file. We can now copy the root user's password hash and crack it on our local machine using the same method we used in a previous section on weak file permissions. Again, the password of password123 is revealed. Back on the Debian VM, we can use the su command to switch to the root user using this password. Environment variables. Programs run through Sudo can inherit the environment variables from the user's environment. In the /etc/sudoers config file, if the env_reset option is set, Sudo will run programs in a new minimal environment. The env_keep option can be used to keep certain environment variables from the user's environment. The configured options are displayed when running sudo-l. ld_preload. ld_preload is an environment variable which can be set to the path of a shared object file. When set, the shared object will be loaded before any others. By creating a custom shared object and creating an init function, we can execute code as soon as the object is loaded. There are a few limitations. ld_preload will not work if the real user ID is different from the effective user ID. Also, Sudo must be configured to preserve the ld_preload environment variable using the env_keep option. If we list the programs our user is allowed to run via Sudo, we can see that the env_keep option includes the ld_preload environment variable. I've created a file called preload.c with the following contents, which should spawn a shell when loaded. I'll compile the code into a shared object located in the /temp directory. Now, if we run any allowed program using Sudo, while setting the ld_preload environment variable to the full path of the shared object we just created, we should get a root shell. LD library path. The LD library path environment variable contains a set of directories where shared libraries are searched for first. The LDD command can be used to print the shared libraries used by a program. By creating a shared library with the same name as one used by a program, and setting LD library path to its parent directory, the program will load our shared library instead. If we once again list the programs our user can run using Sudo, we can see that the ld_library_path environment variable is preserved. Let's run the LDD command against the Apache 2 program. We're going to pick one of these shared objects to replace. In this example, we will use the libcrypt.so.1 shared object. I've created a file called library_path.c with the following contents, which should spawn a shell when loaded. I'll compile the library_path.c file into a shared object with the same name as the one we want to replace. In this case, libcrypt.so.1. Finally, we will run Apache 2 using Sudo while setting the ld_library_path environment variable to the current directory, which is where we compiled our replacement shared object. The shared object is loaded and spawns a root shell.